basic assessment of stream conditions by commission staff. In September of 2019, we verified that the improvements recommended by the remediation plan were implemented, and in October we sent a letter verifying that to the operator. So as our basic timeline, in 2016 we did a site visit to identify the stream diversion in question. In 2017 we did 2 hydrological flow measurements and ditch measurements and stream habitat surveys in July and December. In October we did the implementation, made additional flow measurements, and next week we are following up with those flow measurements as long as conditions are appropriate. And this summer we propose to do a follow-up habitat survey. So the flow measurements made to date, in July and December of 2017, we measured 0.98 MGD above the diversion and 13.5 MGD above the diversion. And as you can tell, flow conditions are highly variable and dependent on rainfall conditions, antecedent to rainfall conditions that occurred prior to the flow measurement. And then in this latest one, we measured 3.78 MGD. These are the flow measurements in the ditch. So prior to implementation, you can see that all of the water was flowing into the ditch during low flow conditions. There is a little bit of leakage, and I'll point that out, through the dam itself. And following implementation of the IFS 1.5 MGD, about 1.75 was flowing in the stream, which maintained the wetted pathway downstream. So this is our 2017 site visit during fairly low flow conditions. This is downstream direction. This is the dam across the stream constructed during the plantation era. This is a point upstream of the dam during when 0.98 MGD were measured, and this is the downstream direction. As you can see, most of the substrate is bedrock or boulder. We found no native biota in the stream in 2017, upstream or downstream of the diversion. We surveyed 5 points upstream, 5 points downstream at, I think, 1,000-foot intervals, but off the top of my head. There's another view of the stream during low flow conditions. This is the diversion intake, this opening right here. This is the diversion dam, and this is the ditch during low flow conditions. Again, almost all of the water during low flow conditions was being removed by the ditch. You can see this pathway is dry completely. This 0.1 is the leakage from the dam. During the high flow measurement event in December 2017, you can see that this is the forebay. A lot of water that was diverted was being returned to the stream. Anything in excess of the maximum capacity of the forebay. This is that same location, but during lower flow conditions following implementation. You can see no water is being spilled, and all the water, there is an IFS, so the water is remaining in the stream, and whatever water is being diverted is being used. This is another, this is during the implementation site visit, so 3.78 MGD was in the stream, more than that low flow condition measured in 2017, but less than that high flow condition. And stop me if you have any questions. Again, the downstream is left to right. This is the intake right here. This is the concrete wall. There's, again, leakage underneath the dam. You can see there's water flowing past it. This is an upstream view of that general location. Leakage past the dam. So this is the IFS that's being implemented. So there's modification to the intake where this board was secured to the ditch and repairs were made to the intake, and an IFS was being met through this channel. And it's a nice ramped slope, so it provides a connectivity flow. These panning boards can be secured in place, and additional ones can be added if needed. This is to maintain a continuous wetted flow downstream of 1.5 million gallons per day. There is a piece of rebar that was secured in the channel, and based on the hydrologic characteristics of the opening, 5.5 inches was needed to maintain at least 1.5 MGD in the stream, and that's the height of the rebar. So it's fairly easy for the operator of the system to go in and see whether the 5.5 inches is being met. If not, then they can add additional boards to the intake. This is another view. So during this flow measurement, 1.74 MGD was remaining in the stream, and 2.04 MGD was going in the ditch.
And Aaron, this is the Malcolmos diversion. Yeah,
This is the diversion that received the stream diversion works permit.
Okay.
In 2015. Okay. There is another registration that's much higher, but that wasn't part of this.
But it's not feeding the system.
That's another view of the water remaining in the stream. And the water entering the forebay and stock. This is the hydropower plant, and the release, the tail race right here, releases into the adjacent stream, which is covered in California grass and other non-native species. So that is all I have.
Is there, there was no native wildlife seen in the stream?
No native biota that we surveyed that we found in 2017, upstream or downstream of the diversion. In 1990, some lentipes, Concolor, the Alamo were found in the stream, but the only other survey done in 1967 found no native species. So we have spotty record of survey coverage, obviously, but this stream does run dry in places, especially during no rainfall conditions. It's very porous, so it doesn't have a lot of base flow.
Does the end go over a cliff or?
Does it have a terminal waterfall? I don't know. But it was the White Stream assessment rated it as low priority. It has the riparian vegetation is mostly non-native species. Just in the 3 years that I have visited, the Myconia has moved in, and so the non-native, a lot of vertical Myconia, strawberry bottle, so that's an issue as well.
What's the elevation of it? Just
1,500 feet.
1,500 feet.
The diversion is more out, 18 maybe.
Thank you. So, Aaron, our action, we already approved this.
Yeah, this is not an action item, this is just an informational brief.
Oh, okay.
So, looks like it worked, the diversion.
So the implementation, and we're gonna follow up next week. During low flow conditions, we're keeping a constant flow path downstream.
And is there connectivity off to Makai?
Yeah. So there's no control gate.
Except in low flow conditions.
So there's no gate here that would restrict any movement.
There is
It's
one.
just free flowing.
There is
You
one.
know, we're gonna have public testimony in a little while, so.
And can you just what are the downstream users of this stream?
Off the top of my head.
I mean, the reason the IFS is strictly to maintain native elder, or there's.
It's a connectivity flow,
Yeah.
down for continual wetted path downstream.
But deep, one of those deep,
It's-
cultures.
yeah.
Okay.
And we can ask Dara to have a look in a few years and see if we can.
We can request that they, they do follow-up surveys, that,
In their spare time.
yeah, exactly.
Are there similar streams of this nature in Namakua that does have native biota?
Yeah, there's, definitely potential for that, and that's why connectivity is important.
Cause it could be ranked as a low priority because it didn't have any connectivity.
The Hawaii Stream Assessment was done in 1890, it was before there was much information on the biota and cultural resources, but based on the best available information at the time, it was ranked low.
Aaron, is there any benefit to the stream where the waters, are released after the?
Yeah, it's the actual ditch itself is a fairly short section, so whatever water bypasses the hydro and goes back in the stream does provide downstream flow.
What stream
But
is
it
that?
goes into different stream.
Oh, you're talking about through the tailrace.
Yeah.
That stream is a very small stream, there's very little, upstream catchment before the tail, or upstream of the tailrace. It's discharging water into kind of a marshy area that's choked with California grass. It is a tributary of the next stream over, so, so it's right here, tributary of this stream.
But it doesn't,
Yeah, DAR has very spotty information, very few surveys done after 1990 on the whole Hamakua coast, so.
Okay, any other questions? Okay, let's go to public testimony.
Mahalo, everybody. Thank you for giving me the opportunity